Good afternoon, everyone, and thank you for joining us. My name is James Lamar Foster, and I'm a Data Science for Social Good Fellow, along with Delaney Glass, Christopher Salazar, and Mahadir Tamene. We're excited to share with you the work we have been conducting for the past 10 weeks on the Seattle 15 Minimum Wage Ordinance and workers' mobility. But before we start, I have to acknowledge the leadership and support we received from our project lead, Jenny, and the eScience Institute data scientists, Jose and Valentina.
People are struggling to make ends meet. Despite movement for fair wages and a fight for 15 across many American cities, housing prices are rising faster than income, leading to increased rent burden and eventual displacement of many low-income, historically marginalized families. As one of the wealthiest cities in the US, Seattle serves as an epicenter and useful case study for how raised minimum wage policies and increased affluence intersect to impact low-wage workers and their families. Seattle passed a $15 minimum wage ordinance in 2014 that took effect in 2015. Simultaneously, the city experienced a large tech boom, which increased the population of high wage earners into the city. Exacerbated by the tech boom, housing prices have shot up faster than in any major city in the US for most of the past several years, and development of high-end luxury housing continue to pop up with fervor and speed. All of this has led to further gentrification and displacement of low-wage workers. Using rich longitudinal data known as WMLAD, which we'll talk about, our project explores the impacts of Seattle's $15 minimum wage ordinance on the city's low-wage workers in context of this coinciding tech boom and its consequences. And we do this by asking a few questions to really understand what the impacts are. We ask, who are low-wage workers and where do they live over time? And we define low wage as 2 times the Washington minimum wage. We'll talk a bit about that later. How much do they spend on housing? When we think about that, we're really interested in the extent of their rent burden, which we define as spending 30%, spending more than 30% of their monthly income on housing. Are they moving over time? We look at that by looking at changes in their home addresses, measuring it as move, and understanding the increased number of moves as a potential indicator of residential displacement or instability. And finally, what are changes in their commute patterns? We do this by looking at home and work address distances using the midpoint of census tract locations of these 2 locations.
So the next question for us is, how do we begin to answer some of these questions? And there have been some previous studies done, particularly from the University of Washington's minimum wage study that asked the initial question, what was the impact of the Seattle minimum wage on employment and earnings? And they did this by looking at employment security department data, which was available to them. And that information includes work locations, earnings, and hours worked. So you can begin to see, you can do some sort of analysis using this information. However, if you change the question to something from our study, for instance, how has work commute changed for Seattle workers over the implementation of the minimum wage ordinance? Well, now we're missing information. We don't have home locations, we don't have residential addresses, so there's no path to do some sort of analysis. So we need more data. And what we can start to do is actually introducing these other agencies from the state of Washington that do have a little bit more rich data. So for example, the Department of Social Health, the Department of Social and Health Services or the Department of Licensing does have home and residential locations. So if we can merge this with the employment security data, we have this merged data set. This merged data set can have home locations, work locations, wages, and from then you can actually see a path to try to answer the question above. And so what that leads us to is this merging of all this information together in all these agencies, and that gives us to WMLAD. WMLAD stands for Washington Merged Longitudinal Administrative Data. And at a high level, it comprises of longitudinal and geo-encoded administrative data from these 7 state agencies from the state of Washington. Now, this is important because we're now able to dig deeper on some of these minimum wage type questions, because we have important social and economic indicators that will drive these questions a little bit further. And there's a few unique things about this. One, we actually have a lot of population captured here. For instance, we have millions of workers, millions of clients, and millions of voters. So we have a pretty large population. Another distinction about this type of data is that Washington State is one of 4 states in the nation that actually reports hours worked. And overall, this is just not something that's available to from cities and governments that provide for researchers to look at. So we're in a unique position that we're amongst the first to look at this data. And part of our goal is to set a foundation for working with this type of data. Now, we have to be very conscious of the fact that we are working with sensitive information here. We can identify a person, and we have to be very conscious about that. So any privacy guidelines we have to abide by. And so that really sort of structures our workflow. And that workflow is kind of demonstrated here and illustrated in this diagram. For starters, WMLAD is a lot of data. In its raw form, it's about 100 gigs worth of data. But as other researchers begin to add data frames and start doing their own analysis, this can really balloon up into the terabytes of data range. Now, when we talk about terabytes of data, we consider that to be big data, and big data has its own challenges to overcome. But just putting that aside for a moment, maybe a bigger question is, where do we store this data in a secure location? And the answer to that is the enclave, or so-called enclave. Now, the enclave is a remote server that's hosted by the Center for Studies in Demography and Ecology, and it's from the University of Washington. And it's just a place that we as researchers can actually log into. But there's one slight caveat to it, is that there's no connection to the internet. And for good reason, right? We don't want to be able to send files over and transfer files over the internet. But it does impact the entire workflow. We don't typically work in this environment. So for instance, Git or GitHub is a collaborative platform for programmers to use. And it really synchronizes well with the internet, but we don't have that. So we have to kind of work in a sort of version of it. RStudio and SQL are the coding platforms that we use. But again, everything has to be developed within the enclave. And within all of this, we have to make sure that we keep everything private and abide by all the privacy guidelines. So anything that comes out of the enclave has to be approved as an extra set of eyes. And what I'm really just trying to emphasize here is that we're not only working with big data, we're working with big, sensitive administrative data. So with that framework in mind, we can actually move on to some findings.
We want to emphasize that the findings we are about to discuss are exploratory and ongoing. Please contact our project lead, Jenny, if you would like to cite anything presented. The unit of analysis for our study are low-wage workers. As a result, we need to clearly define what it means to be a low-wage worker. After extensive review of the literature, we found that there is not a consensus for what constitutes a low-wage worker. For example, the Brookings Institute's 2019 report on low-wage workers defined low-wage workers as individuals making less than 2/3 the median wage for full-time workers. Furthermore, other studies have defined low-wage workers as people making less than $13 per hour or people making $25,000 a year. If we decided to use 2 times the Washington State minimum wage in order to account for inflation and the rising cost of goods and services. By doing this, the minimum wage for 2015 came out to be around $19 per hour, which aligned with Jardim and her colleagues' 2017 paper on the Seattle minimum wage, where they used a $19 cutoff for the 2016 Seattle workers. The next thing we wanted to do was understand who Seattle low-wage workers were. We found that the percentage of low-wage workers by race is proportionate to the racial makeup of the Puget Sound residents, as you can see by looking at this donut plot. The next thing we wanted to know was where low-wage Seattle workers lived over time. Take a moment to look at this animated map. The lighter colors indicate a higher proportion of low-wage Seattle workers. As time progresses, we see more and more low-wage workers. In particular, we see them moving further away from the Seattle region.
In addition to figuring out who the low-wage workers were and where they were living, we also were interested in how much these Seattle low-wage workers spend on housing. And so using public available data from Housing and Urban Development, we estimated which proportion of low-wage workers were likely to be rent burdened. In other words, they're spending greater than 30% of their earnings on rent. And in 2011, when the state minimum wage was around $8.67 per hour, you can see on the lower right that pretty much 100% or close to 100% of all low-wage workers in Seattle were rent burdened. And in 2016, there's a slight contrast. We do see a decrease in the proportion of workers, of low-wage workers who are rent burdened or likely rent burdened. And in the outskirts of the Puget Sound region, we actually see an increase. And so it could be that low-wage workers, or one explanation could be that low-wage workers are moving out of the city, or that the minimum wage increase is actually helping workers to afford their rent. However, in Seattle proper, it's also plausible that only the low-wage workers who can afford to stay are staying.
We also took a look at movement, trying to understand movement to really test this idea of whether low-wage workers are being displaced as a consequence of this influx of affluence into the city. So this graph looks at how many times Seattle workers have ever moved between 2010 and 2017, and really increased moves for us served as a potential indicator of displacement. And so we see a count of different moves on the x-axis, and you'll see the number of workers. And what we see is that low-wage workers have a greater number of total moves, being more likely to move 4+ times. And of note, the common cutoffs for defining high mobility or residential instability within the literature are about 3 or 4 moves. So these exploratory findings show some indication of displacement that's worth further exploration. In attempting to understand change in residence of Seattle workers over time, this following graph looks at the number of workers by wage status and residence, or where Seattle and non-Seattle residents live across time. And I just wanted to highlight a key point here, and that is over time, we see that the number of non-low wage workers living in Seattle, seen here in the purple, is increasing over time, which indicates a general proportional decrease of low wage workers living in Seattle. This supports the visualization Lamar showed earlier that highlights a proportion of low wage workers living in the city decreasing over time, while proportion in the outskirts or outside of Seattle is increasing. So again, we're seeing some patterns indicating that low wage workers are moving more frequently and likely moving out of the city and into the outskirts as time progresses.
And as we begin to answer the question of what changes in low-wage workers in their commuting patterns, one thing we have to keep in mind is that if we have home information and we have work information as well, if you really worked hard enough, you can actually identify a person based on some of these simple attributes. So a way to mitigate this is that we want to de-identify a person even further by looking at everything at the census tract level. So here you see an image of King County's census tracts. And every single blue dot represents the midpoint of that census tract. And the way that we go about this is, the midpoint itself is just some arbitrary point that's, again, just a midpoint. So what we do is we take every observation of an individual, we have a home location, and we tie their home location to some census tract, and that census tract is then tied to a census tract midpoint. Then that midpoint, we use the same thing for the work location. And then what we do is we connect the dots and we calculate some sort of commute based on those 2 points. So with this in mind, we can begin to have we can begin to do some level of analysis. For instance, we can start to look at the average commuting distance for Seattle workers. And here we see this graph on the y-axis, we have average commuting distance in miles, and on the x-axis, we see the years over time. And upon first glance, we look at the wage brackets between low and non-low, with the red representing the low wage type workers. And if anything, we might say there's not really much of a difference considering the scale here. And also, if anything, we might even say that low wage workers might enjoy lower commute time in general. However, if we start to change the granularity of the wage bracket, now instead considering low wage workers, medium wage, and high wage, where low wage is still less than 2 times the minimum wage, medium between 2 and 4, and high is greater than 4, well, perhaps we actually uncover a pattern here, or reveal something a little bit more closely. Now we see that the red line is actually, after 2013, begins to surpass the high wage worker commute. And again, this is just more of an exploratory, but I think it really points to the fact that this data can start to reveal these things because we can go to different levels of granularity overall. So again, just emphasizing the power of what this data can provide and what different things we can uncover.
And in sum, among Seattle low-wage workers, we really do find some initial suspicions that rent burden persists over time, even if it was decreasing, and that low-wage workers tend to have greater moves overall, and they are moving out of the city at a greater rate. And as a team, we really advocate that $15 is not enough, and this is in line with what many past labor and housing advocates are really pushing for. And we agree with this sentiment, and we believe that there should be more investment in publicly funded affordable housing and a greater minimum wage to address simultaneously the crises of housing and income inequality. And we really believe that our research here and that future WMLAD users can begin to sort of probe the effects of the minimum wage even further, in addition to our exploratory analysis. So for example, future researchers may consider doing some formal statistical modeling, perhaps predictive or inferential, to understand what happened in the past decade and then what might occur in the future when it comes to income inequality and basically the overall quality of life for low-wage workers. We also contend that they should use household level data. We mostly looked at individual data, and this can be particularly useful for things like rent burden, because rent burden is typically calculated at the household level rather than the individual level. We also believe that future researchers should build cohorts. Although the WMLAD data represents millions of observations and millions of people, we did not look at a longitudinal cohort over time in all of our analyses. And so we strongly believe that future researchers should build cohorts to better understand longitudinal change. And in doing so, they may also refine metrics to, for example, understand changes in commute patterns more at the different levels, zip code, census block, census tract, and then also to understand potential racial disparities among low-wage workers as well.
There are also some WMLAD considerations. First, we suggest people leverage administrative data. Once again, this data was not intended for statistical analyses. However, because it is exhaustive, researchers can use it to uncover issues that have policy implications by conducting geospatial analyses. However, users of administrative data need to use this data with a critical lens. This data is highly sensitive. Each observation is a person and should be treated as such. Lastly, the reason we were able to scratch the surface of this data is because there was an investment in collecting and merging all of this data. This kind of investment should not stop at 2017. There needs to be a continued investment in collecting and merging administrative data for future research and advocacy. And lastly, we want to conclude by thanking our many supporters and sponsors. This work would not have been possible without your collective effort. Thank you.